Hey, this is Dr. B, and for our Science in the News presentation, I've chosen the Ingenuity Helicopter. Now imagine a very large rocket ship which is going to be launching, hang on, tomorrow. Uh, Imagine it traveling through space for like months until it arrives on Mars, at which point, by a pretty complex process, but one that has been successful for NASA in the past, it deploys the Perseverance uh, car vehicle, and on the bottom of it, there's a little drone. This is known as the Ingenuity Helicopter. Rather than have me describe it, I'm going to go ahead and show you this video and maybe a little bit of this video, and then we'll ask some questions. Okay, so that's a little bit about the Ingenuity Helicopter. This one might also autoplay. I do want to mention, I do want to also mention that this is a great source here, this NASA briefing. I'll just show it to you briefly. This is a great source for information that was created by NASA themselves. So have a look at this if you want to get some more information. It's very well done, and it can very quickly give you a lot of useful information. So let's go back. There it goes. Now, for your assignment, answer the following questions. When does it launch? When does it arrive on Mars? How far away is Mars? And then do the math and figure out how fast it had to go in order to get there at that time frame, right? And at that distance. And some other questions. Why is it hard to fly on Mars? It could be very challenging. There's some things that work against you. There's maybe one or two things that might work for you. How long are those daily flights which are going to be taken by the Ingenuity helicopter? And two, calculations. Well, how much energy does it get from the sun each day, for starters? And for this, if you're having trouble with this calculation, you can take a look at this Wired resource. And here's what we'll assume: that the sun provides 300 watts per square meter per day. The solar panel has an area of 154 square centimeters. Notice this is square meters here. And we'll assume it's 25% efficient. And from that, we should be able to, given this watts to joules conversion, come up with how many joules of energy that solar panel can suck up realistically each day. Now, if you know that, let's compare the amount of energy that that has to your average cell phone. So the cell phone I chose was the iPhone 11. Let us assume this is a 4,000 milliampere hour battery. They just usually write mAh, operating at 3.8 volts. And if you take joules, multiply it by, if you take your milliampere hours, multiply it by 3.6, and then by the voltage, you can very quickly get the energy of a battery in joules. Compare that to this number, and that should give you some idea of how much energy this thing has to work with each day. If the real problem, of course, for engineers is given that amount of energy, how can they create a helicopter that can fly for as long as possible, given that energy constraint? And finally, what fascinates you most about the Ingenuity helicopter? Please write one paragraph or much more if you so desire.